Hello, algebra students. Welcome back. This is part 2 of radicals and exponents. Sorry we got cut off at the end of the last video, but let's move on. So now we have a few example problems. Keep in mind when we're working on problems such as this or this, that radicals and exponents relate to one another. So if you remember in our last slide that when you take a number such as 16 to the 1/2 power, that 1/2 exponent is really relating to the root. So this number right here is the root. So in this case it's the second root or the square root of 16, which we said before would just equal 4. Because 4 times 4 is 16. So kind of look at this one the same way. This is no longer the second root, it's the third root. So we can rewrite that as the third root. And when you write square root, you don't have to write the 2 there, but when we're writing our third root, we do have to put a 3 there. So this is the third root of 125. And this number we can actually simplify. We don't always simplify them if we can't, but this one we can. So thinking of the third root, what number times itself times itself times itself will give you 125? Take a few seconds to think about it. Pause the video, and then I'll tell you when we hit play. Did you really pause? It's cheating if you don't. Okay, so the cube root of 125 would just be 5, because 5 times 5 times 5 multiplied 3 times, thus the third root gives you 125. Okay, now we're going to need some more space for the second problem. Alright, we're rewriting this expression as radicals. It's 5 to the 2/3. You know, these exponent things were bad enough, but now you start throwing fractions in there, and it's no longer just fractions with 1 in your numerator. We have 2/3. So what does that look like? Well, I'm going to rewrite this over here, 5 to the 2/3. Easy way to think of it is, if I were to cover up this 3 here, just imagine crossing this out, this would still be 5 to the second power, right? Okay, so let's do that. 5 to the second power is just 5 times 5, right? Okay, so we have taken care of this part of it. We need to take care of this part. So when it's to the 1/3 power, and you can just imagine there's a 1 there, 1/3, like we did here, we make it to the third root. So since we've already taken 5 squared, now all we have to do is add the third root. So this is 5 times 5, which we can just simplify that to 25. And final answer here is the 5 to the 2/3 power is equal to 25, the third root of 25. Okay? Now I would like you to try these next two problems on your own. Alright? So hit pause. In your notes, you should be still adding these to the body of your notes. Do these two problems, rewriting them as radical expressions, just like we did before. Hit pause. Alright, since you paused and did these in your notes like a good student, now I'm just going to shift the screen a little bit so we can answer this problem. Hopefully you got as an answer, this whole quantity of x minus 4 is written to the 1/2 power. That's no big deal. We're just going to write that to the square root. And again, if it's of the entire thing. You have parentheses, don't have parentheses, either way, that's how it should look. Okay, did you get it right? Yay! Good job. How about this next one? Again, we're doing 2 to the 5th power, which is 2 times 2 times 2 times 2 times 2. If you multiply that out, you get 32. So it's almost like, again, we just ignore this denominator for a second and then apply that root. So now we do 32 to the third root. And if you have a scientific calculator, you could come up with a decimal equivalent of that. But we're going to stop right there and just leave that as our final answer because it is in radical form. Now later on in the year we'll learn how to simplify radicals, but for right now I think you can leave that alone. Did you get that one right? Great job. Okay, so now let's look at the opposite end. How can we rewrite these radicals as exponents? This is kind of easy. Take what's inside the radical right here, and we're going to turn this third root into an exponent. It just becomes 20 to the 1/3 power. You knew that, and of course my handwriting is not very neat. Writing with my finger on the screen. Why don't you try these next two problems, put them in your notes, and right now, hit pause. Alright, hopefully you did these problems on your own, and if you didn't, I guess you can always rewind. What you'll see is this one's pretty straightforward. This can be written as x plus 2 as a quantity to the 1/5 power. That's what the fifth root means. Now this one, I don't have the full answer here, but we have 2/3 to the 4th root. So 2/3 can be written to the 1/4 power, but we can keep simplifying there. I'm going to change this to 2 as my base. That stays the same, but let's think about this. When you have an parentheses here, this is taking a power to a power, and we're going to go into this a little bit more detail in the next slide, but this number gets multiplied by this number, so it's almost like you could say this is 3 over 1 times 1 over 4. And in case you forgot, multiplying fractions, 3 times 1 would just give you 3, and 1 times 4 would just give you 4. So our final answer here is 2 to the 3/4 power is how we would rewrite this expression. Did you get that right? That's awesome if you did. I'm impressed. You deserve a high five tomorrow. Now, this next slide, it would be nice to just tell you to take a picture of it so you remember. It's in the book, but taking a picture doesn't help you remember it. So if you can take a mental picture of this, this is a lot of the properties that will help you and what you can do with them. Might make a good idea to write down, let's see, this part right now. Hit pause, put those in your notes, and we'll talk about this part in just a second. Alright, did you take some time to write that down? If you didn't, I really suggest you hit pause because it's going to take a while for me to go through this, but it's not going to take that long to where you can't write it. You're going to have time to write it all down and pay attention. So pay attention. Here we go. So what this first property says is if you're multiplying and you have exponents, for instance 2 to the 2nd power, 2 to the 3rd, notice that the bases are the same, 2 and 2. If the bases are the same, the rule is you keep that base, add your exponents. 2 plus 3 gives you 5. And of course you can simplify that to 2 to the 5th power is equal to 32. Another way to think of it is like this. If you had 2 squared and 2 to the 3rd, if I wrote this out long way, this would be 2 times 2. And 2 to the 3rd would be 2 times 2 times 2. So how many do we have altogether? Well, we have 1, 2, 3, 4, 5. So that is 2 to the 5th power. Now if you're going to do that every single time, it's going to be writing out a lot of numbers. So to save yourself some time, remember the rule. If the bases are the same when you're multiplying with exponents, keep the base, add the exponents. If you're going to ask the question, if these bases are different, well, then we're not talking about this rule anymore. And you just have to multiply it out or simplify as needed. Alright, here's our next rule. It deals with quotients, which means dividing. So we have a to the m power over a to the n power. Notice that the bases are the same, they're both a. We are dividing. What you need to do is simply keep the base, subtract the exponents. So in a numeric example right here, we have 2 to the 5th over 2 to the 3rd. Both bases are the same, 2 and 2. We keep the base, 2. 5 minus 3, we subtract, gives you the base of 2, which of course simplifies to 4. Okay, so first rule, if you're multiplying and bases are the same, keep the base, add the exponents. If we're dividing, bases are the same, keep the base, subtract the exponents. Now for our next example, take a look right here. Notice that we have two numbers being multiplied, and then there's this parentheses, and there's an n on the outside. So the exponent is being applied to the parentheses. Well, what that means is you can basically apply this and distribute it to both variables here. So a times b in parentheses will equal a to the nth power times b to the nth power. So looking at that with numbers, there's a couple ways you can do it. Now with numbers, you probably would just multiply here. 2 times 3 is 6, and you square that, you get 36. But it also works distributing this exponent to both of the numbers. Now 2 times 3 to the second power is 3 times 3, which is 9. 2 to the second power is 2 times 2, which is 4. 4 times 9 would also give you 36. So it works out either way. But when you're dealing with variables, this is another way to rewrite it. I like this way to think about it too. These two are very related. If you have a exponent inside the parentheses and then there's one outside, this is like taking a power to a power. And how this n gets distributed here, same thing. This n gets distributed to m, so it becomes m times n. And we multiply. So when you have a power to a power, keep the base, a stays the same, multiply the exponents, m times n, we just write it as mn. Okay, so a little confusing, but oh, and they used a lot of 2's here. Great. So we have 2 to the second power. If you have an exponent out here, we're going to keep this base, 2, multiply these exponents, 2 times 2 is 4, 2 to the fourth power simplifies to 16. Another useful rule is here. When you have a fraction to an exponent, you can think of it as like the exponent is applied to the numerator and denominator. So if we had 1/2 squared, oh my gosh, fractions and exponents, what are we going to do? You just square 1. 1 times 1 is 1. Square 2, the denominator, 2 times 2 is 4. And the last one, we kind of already talked about this. When you have a number to the negative exponent, it's the same thing as saying the reciprocal of that, or 1 over that. So in this example, 2 to the negative 2 power is the same thing as 1 over 2 to the second power. And 2 to the second power is 4, so that's how we get 1/4. Remember with these kinds of problems is negative exponents don't make you dumber, because negative exponents don't make negative numbers. Negative exponents have much action because negative exponents make fractions. Notice this is not negative 1/4. It's just 2 to the negative 2 power gives you positive 1/4. Okay, so take a few seconds, look back over these. I know that was a lot. It's important stuff. We're going to work on it more in class, but pause the video, relook at your notes, see if any of this makes sense. If you have questions, put question marks in your note and we'll talk about them in class. Alright, now it's my favorite time of the video because it's your turn to work. So I have 9 examples here. These are exponents with fractions as the exponents. Oh my gosh, let's see if you were paying attention. See if you can simplify all these expressions. So hit pause and I'll put the answers after this in just a few seconds. You can check your answers with what you get. I want you to try all 9 on your own. And then if you have any questions, we can talk about this tomorrow. Okay? Hit pause. Alright, here are your answers. 100 to the 1/2 power is the square root of 100, which is equals 10. Notice it's not 50, we're not dividing by 2. 10 times 10 is 100, so that's why it's the square root. Okay, square root, or the cube root of 1,000 is also 10, because 10 times 10 times 10 gives you 1,000. The fifth root of 32 is 2, because 2 times 2 times 2 times 2 is 32. I hope I said 2 enough times. 25 to the 1/2 power, square root of 25 is 5. Square root of, or the fourth root of 81 is 3, because 3 times 3 times 3 times 3 will give you 81. And then we just have to add those. 5 plus 3, final answer, 8. 216 to the third root, well, that might, you have to try a few things. 6 times 6 times 6 gives us 216, so the third root of 216 is 6. Same deal here. 3 times 3 times 3 is 27, so the third root of 27 is 3. So final answer here, 6 minus 3 is equal to 3. Then we have 81 to the 1/2 root is 9. So the square root of 81 is 9. And the 6th root of 64 is 2. 9 minus 2 is 7. Now that 6th root, the reason why 64 to the 6th root is 2, 2 times 2 times 2 times 2 times 2 times 2 is 64. So yes, there are 6 2's multiplied together to get 64. And what you'll notice is these problems, these kinds of numbers pop up a lot. All right, 7, 8, and 9, they're getting a little trickier here. 1,000 to the 2/3 power is like 1,000 squared, or 1,000 times 1,000, which is 1,000,000. So we're looking for the third root of 1,000,000. And if you test it out, 100 times 100 times 100 will give you 1,000,000. So the third root of 1,000,000 is 100. Okay, so now we probably need some calculator help here. I had to use a little bit of calculator because 27 to the 4th root is 27 times 27 times 27 times 27. A lot to say. And if you multiply that out, you get 531,441. And the third root, because remember this 3 down here, of that gives us 81. Now, this one over here, 64 to the 5/6 power. That's 64 to the 5th power, which is a really big number. And then you're taking it to the 6th root. And after all that, you just get 32. Okay, now I'm sure you have questions. Let's take these questions to the classroom. I just wanted to give you guys a preview. Hopefully you tried this, gave some problems a good shot. Maybe you figured some out. If you did not, please go back, watch parts of the video, find questions you didn't understand, write them down, bring them to me tomorrow. All right, algebra students, great job with our first lesson. Have a good night. Bye-bye.